It just disappeared on me. I'm going to go this way. All right, class. Bam, let's begin. I don't know how far we'll get it to 7.3 right now, but we are going to go through homework questions from 7.2. So give me a list.
I didn't know how to do that.
The last three. 43, 49, 51. Okay. Perfect, because we haven't got into the both times we did 7.1 and 7.2, we didn't get to the application questions. And so let me just see real quickly here. Oh, we got to 43 because the airplane going headwind and tailwind. And let's just kind of start off the other two, because once you start off the other two, they're pretty easy. So let's jam with, let's do 43 first, just to start you guys off. And let's do this here. Start you guys off today. Wednesday, come back if you have any other homework questions from 7.2. If not, then we'll do a due date on Wednesday for 7.2 homework. Okay. 43, airplane flying into a headwind travels 1,800-mile course, flying a distance between Pittsburgh and Phoenix. All right. In 3 hours and 36 minutes. On the return flight, the distance traveled is exactly 3 hours. That's cool. Find the airspeed of the plane, speed of the wind, assuming that both remain constant. So how about this here? I'm going to label R1 is speed of plane. R2 is speed of wind. Thank you, Landon, for getting calculators. Okay, so now we got to figure out where's the headwind and where's the tailwind coming from here. And again, these guys are called dirt problems, with distance being equal to rate times time. So we're going to set up two equations like this. So in both cases, though, we have 1,800 miles to cover. And then the rate would be, we need to figure out when is the tailwind, when is the, so let's see, Pittsburgh to Phoenix. Yeah, chicken scratch. How about PH for Phoenix? Tailwind or headwind? And then Phoenix to Pittsburgh. So from Pittsburgh to Phoenix, it takes 3 hours and 36 minutes. Return flight takes exactly 3 hours. This guy's exactly 3 hours. I don't know. I'm thinking the headwind is right here. And actually, I should write it like this here. So this is the headwind. It took longer to go this direction. So that means it's the speed of the airplane. Speed of the airplane is always going to be first. In this case, though, the wind is going against you. This one only 3 hours. That means you did have a tailwind. And now you got yourself the wind helping you in this case. Cool. And the only other thing that we need is we need to convert this guys into hours. What's 3 hours and 36 minutes just in terms of hours? Three and 3/5. 36 over 60. Divide by 6 each, is that right? 6. 3/5. You can do it like that. We usually don't like fractions, especially in this stuff here. So how about decimals? 0.6 I like. Okay, so I think we got it here. So Pittsburgh to Phoenix, I got myself The rate at which we're flying is R1 minus R2. And the time it took to get there was 3.6. The return flight is R1 plus R2. And now it's only taking exactly 3 hours. Okay, does that set you guys up well? And that's the one that we did on Friday. It's kind of tough to set them up. Once you set them up, then it's like, oh yeah, that's easy. Okay, I'll let you guys solve it though, okay? 49, ding, 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 ding. 49, it says 2 cheeseburgers and 1 small order of fries from a fast food joint contain a total of 850 calories, those people that count calories. 3 cheeseburgers and 2 small orders of fries total 1,390 calories. Find the calorie content of each item. So this is kind of cool. You don't know something, but you know the relationship between 2 things. By knowing that, you can find the individual pieces at that point. Okay, let's start labeling. So cheeseburger, I'm gonna put C for cheeseburger, or cost of cheeseburger. Now F, I'm gonna put is cost for French fries. Okay, are we good there? I got 2 different variables. I wrote them as capital letters. I don't know, you could write them as lowercase letters, but okay. But as far as caloric content is concerned, so notice it says 2 cheeseburgers and 1 small order of French fries gives us 850 calories, exactly what it says. So it looks like 2 C's. I am so sorry, hold on, it's not cost, hold on. Duh, I was thinking money here. It's caloric content, right? Calories. So calories from cheeseburger, calories from French fries are good. Okay, that's what we're looking for. So how about 2 cheeseburgers plus 1 order of fries gets us 850 calories. Now you guys talk to me here. How many did these already and sold them? Okay, cool. Okay, the other way around is 3 cheeseburgers and 2 small fries. Okay, someone's hungry. 3 cheeseburgers plus 2 small fries gets us 1,390 calories. Do I have 2 equations? Yes. Do I have 2 things I don't know? Yes, I can solve this. So your choices are elimination or substitution, whichever one you like. Okay, and let's set up the next one here. 51, 10 liters of 30% acid solution is obtained by mixing 20% solution with a 50% solution. Okay, so this one we didn't cover as much here. Let's see, there's a whole bunch of stuff that says, so write a system of equations in which one equation represents the amount of final mixture required, the others represents the percent of acid in the final mixture. Let X and Y represent the amounts of 20 and 30%. Okay, so they gave you which ones. So X is going to be number of liters of I will not write chicken scratch, my New Year's resolution, even though it is May.
Your happy year's resolution.
Okay, boom and boom. All right, let me read it again, and you guys talk to me. You guys talk to me, see if you can give me a two equations. I just need two equations out of this sentence. We're good? It says 10 liters of a 30% acid solution is obtained by mixing a 20% solution and a 50% solution. Oh, sorry. Guys, real quick here. The final result is a 30% solution, but we have that and that right there. It should be a 50% solution. I like to do these in terms of, I think of something called the quantity equation. T. Just how much, that's the, how much do you have? And then, I call it the quality or the percent solution. How is the quality of it? So the quantity solution, how many liters do we want in total? 10. Yeah, the quantity solution is how many liters of the X plus how many liters of the Y gets us 10. So just one that just gives us the quantity across. That's the cool part. These are pretty easy to set up. Next piece is now the quality or the percent. Sometimes in terms of money, it's the value of something, right? The value of it or the percent of something here. So in this case, it's going to be 20% solution. Right like that. So it would be this plus 50% solution will equal, and notice what's happening here. It's your percent multiplied by how much, right? It's the quantity from earlier. Good. So then it's percent again. So it's 0.50% multiplied by the quantity of Y. So in this case, you're going to get the same thing here. It's going to be the percent of what you want at the end. It's a 30% solution of the 10. So there's your quality equation. Now you're sort of mixing the two together. All right, two equations, all four, go. Good. Thank you for bringing the questions up. Okay, any other questions? Going once, going twice. We're on a roll here. No, okay. All right, let's go. 22.5 minutes. Let's see what we can do.
Are we making a test into the class?
Yeah, we're gonna just right at the end of class. So we got 7.3 multiple variable linear solutions. What in the world is that? All right, just means we're gonna have a whole bunch of them. Say again?
That's not good.
That's not good. So if you want to put on the title here, go for it. Put on the title 7.3 multivariable linear solutions. So far we've had linear and nonlinear systems. We noticed that we solve them by the substitution method. Then we have two linear systems we solve by elimination. Super easy to solve it that way. Multivariable just means we have more than two equations now. We have three. Once you go beyond 4 and 5 and 6 and 7, two things happen here. We either do matrices, which is something we might get to, or we plug it into a software. At that point, you plug in variables, you click crunch, and it starts number crunching for you. Excel spreadsheets, if you set them up correctly, you can do it with them as long as you have the cost. Like if you're running a business, right, you have all the cost pieces that you need, the profit, you have all your distribution pieces, how much it's costing you to do all that, and then you can kind of manipulate the variable. But we're going to go with 3 variables at the same time, and let's go with it here. So example 1, it just says solve. Let's solve this guy. In fact, be already solved here, but here's my equation. X minus 2y plus 3z is equal to 9. Y plus 3z is equal to 5, and z is equal to 2. So notice this is an interesting thing. Do we know what one variable is already? Absolutely. There it is. I know Off to the side, I know this piece right here. I know z equals 2. Sweet. Which means when I start plugging stuff back in, that means perfect. Subtract 6 from both sides. I got y is equal to -1. Perfecto. Let's plug it in again. Oh, hold on. Look, notice we're kind of moving up the chain over here, right? I got this one. I got this one. Now go to this one. This one's going to be now x. I don't know. Y I know to be -1. Z I know to be 2. And can we solve for x? Absolutely. What is that? 8, I think. Oh, sorry, no, it's +8 still, equal to 9, and x is equal to 1. Done. Okay, how do we write these now? Now that we have extra variables, it's going to be whatever the x is, whatever the y is, and whatever the z is. So 1, no matter which order you solve them, because the solving could have happened in a different order. Okay, are we good there? This guy here is called row reduced echelon form.
I'm gonna need spelling on that.
So this process here, there's actually 2 different ways to do this. We could have done this all by substitution. It just takes a long time. And your book doesn't even cover that anymore. I'm not sure why it doesn't cover it anymore. So this little piece right here, notice you have x, y, and z, then you only have the y and the z, and then you only have the z, right? This little process is called row echelon form, or the way they're set up is called row echelon form. You eliminate each of the variables as you go down. Now the process that we do this, now let's get into the process, like how do you do this? How does this all work here? So we're going to do this. It's called, named after Frederick Gauss. It's called Gaussian Elimination. How to make himself famous, right? Frederick. Say again.
Sounds like a type of kill.
Gaussian elimination. You're dead. Frederick Gauss, pretty cool kid. Father was a bookkeeper for the city that they were living in, and he was just he had a little gift for mathematics. In fact, talk to me here. 6th grade or 5th grade, I forget which one. The teacher said, want to give him busy work. 5th grader, like, look, you need to practice with addition. So I want you to do is I want to add, you guys add up all the numbers from 1 to 100. Go, 5th graders. And so, of course, that'd keep him busy for a half an hour easily, right? That's cool. And then they had to do it on chalkboards, because that's what they did. So it was a chalkboard, you had it about a sheet of paper-ish, right? So then what you had to do is you go like this, you go 1, okay, 1 plus 2, I know that's 3. And then maybe you could squeeze in 3 plus 3 would be 6. And then what you do off to the right-hand corner, you put 6 right here. And then what you do is you have to erase all this right here. And then don't forget you're on 4. Don't forget out there. So now I'm going to go 6 plus 4 is 10. Okay, so hold on. Let me erase this. That's 10. Don't forget I'm on 5 now. Oh, tedious. And Frederick Gauss, he said, oh, I see it. Let me give you the hint here. So if I were to add 1 to 100, and it would go like this, wouldn't it? Dot, 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 right? And then 99, then 100, right? Wouldn't that be the same thing as adding 100 back to 1? So if I started with 100 here,
I see it.
then 99 here, and then 98 here, and then if I just kept on going, eventually I wind up with 2 plus 1.
Wow. Yeah.
Oh yeah, that's so cool. So check this out. What does that give us? That's 101. That's 101. Oh, this is awesome.
Or you can just start with 99 and 1.
Yeah.
Yeah,
Yeah, true. Yeah, and then the question is, how many of those do you have? Then yeah.
100 100s or 100 100.
Yeah. So then, how many of these guys here? It's going to be 100 of those, right? So he goes, oh, that is so cool. So hold on, what in the world is this right here? Oh, hold on. No, not that, because I've done double, right? 50. Okay, so I'm going to chop this one. I'm going to put 50 here. Put 101. And talk to me. What would that be? What would be 50 times?
50,500.
Ooh. 5,000. I'll go by that. Yeah. You know, overjoyed fifth grader. You know, he's like, "Oh, that is so cool! Check this out." So he's like,
Probably not that happy.
he puts in 5050. He's like, "Look, teacher, look what I did." Teacher did not care one bit. Get to your seat. What are you doing? Just get to your seat. Start adding it up. So I'm glad that didn't kill his spirit, because he went on to do brilliant mathematics afterwards here. He questioned a lot of the presuppositions of the early Greeks as well with mathematics, and corrected a few things here, and that was cool too. And went from there. Anyways, let's go. Gaussian elimination. So he developed a system which you can simplify equations all the way down to what we just saw earlier here. So let's jam exercise 2. Let's do an easy one, then we'll do a more difficult one. Easy one, let's start. 3x minus 2y is equal to 1, or negative 1. X minus y is equal to 0. Now, we could have done this by elimination. We could do this by substitution. No problem whatsoever. What he did is he said, okay, so again, it's a process, right? Let's think of this there. So he said, look, I'm gonna put the easiest equation on top. And that's gonna be my top equation. Then I'm gonna work down from there. So easiest equation on top. Is this the same thing as writing like this? Is that the same thing? Yeah, okay, so we're gonna develop some rules here. So if I have multiple equations, I can interchange either one of them anytime I like. It doesn't change my problem whatsoever. So he said, okay, well, hold on, remember how we do elimination? Elimination is done by getting one opposites, right? And adding them together, right? And then you get an extra, you get another equation underneath it, right? That makes sense. Let's do this here. So he said, I'm going to write the first one down. My simple equation, I'm going to write down lower, right here. That's lower. To get this other one here, I'm going to do a little bit of work on the side. I'm going to do this here. I'm going to multiply. I'm going to create opposites, essentially. That's what I'm going to do. Now I'm going to get rid of my first variable. So off to the side, this is not what we put down. Off to the side, what do we do to create opposites for x? So I need an opposite for x between these guys right there. Multiply by -3, is that right? So off to the world of mental math over here. We just say -3x plus 3y is equal to 0. Easy about that, okay? We're multiplying the top equation by -3 to create the opposite for the x. And then the question becomes, if I add this up together, what do I get? X's are gone, right? It'd be gone.
Y equals -4.
Cool, I'm gonna write this equation back into this little formula right here. Ah, come on.
Well, once you see x minus y equals 0, don't you have that x equals y too? So once you find y, you find the other. Or no, x equals -1, or whatever, like 1 and -1 or 2.
Yeah, this is an easy one, yeah, because you can switch this around, say X and Y are both the same number, and go from there. This is the process. We'll get into some tougher ones here in just a second here. Okay, so off to the side, we do elimination off to the side, and we bring it down into here. Once we've solved for our two variables, we plug it back in. We start plugging what we did for example 1. You know what y is equal to -1? You plug into your previous equation, which is x minus -1 is equal to 0. X plus 1 equals 0, x is equal to -1 as well. So answer is -1, -1. Are we good? Again, easy example. Whole bunch of easier way to do this than this process. But let's go on to a little tougher one now. Okay, let's see how this process works with tougher equations here. Okay, ready for example 3? Let's jam. Okay, this is the serious one now. Here's what I have to solve. X minus 2y plus 3z is equal to 9. Negative x plus 3y is equal to -4. Oh, I'm missing variables here. 2x minus 5y plus 5z is equal to 17. Just make sure I go down correctly here. Okay, so first things first. Ding, 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 ding. Ready? It's a process, so almost like you have to build the skill for it, right? So you got to practice with some ideas in mathematics, just like we did, adding 1 to 100. Notice on that one, it's like once you see it, it's like, oh, that's so cool. It works, right? And that's more conceptual, it's more ideas of mathematics. This one is going to be a process, so it's a skill of mathematics. So first things first, we have to get the x. That's the most simplest x in the whole entire world. Usually we want x with the coefficient of 1. So on the top equation, do we have x with a coefficient of 1? Yes. That means we don't have to change anything around. We good? So first equation is set. We write it down over here. Ding, ding, ding. Second equation, we're going to create opposites and kill off the x underneath. So off to the side, in our imaginary world of elimination, question is, do I have opposites for my x's? Absolutely. Notice I do no change over here, right? No change gets me x minus 2y plus 3z is equal to 9. No change also gets me negative x plus 3y is equal to -4. Can you add those guys up together? Did we get rid of x's? Absolutely. What is, let's see, -2y plus 3y is just the y. 3z plus nothing gets me 3z. And 9 plus -4. 5. That becomes my new equation underneath. Next is we got this little piece right here. Our elimination imaginary world. We got another one. Now we're going to do the top equation and the bottom equation. Do I need to multiply anything to create an opposite? And usually you're gonna multiply the top equation by something to create the opposite. So talk to me if we're still awake. What do I multiply this guy, this x is, to create opposite?
Multiply by 2.
Ooh, so close, Abe, so close. -2. So here we multiply by -2. So if you want, just put in this -2 here. The bottom equation almost always going to be a no change equation. You just deal with the top equation. That's why you want this guy to be as simple as possible, because you want to be able to multiply things. Positive or negative numbers, who cares? Okay, multiply by 2 by negative da. I got myself a 4y. Talk to me if this is true. This is a minus 6z, is that right? And minus 18. Bottom equation remains exactly the same. Are we going to get rid of our x value? Yes, that's done. Next is negative z. Negative z is equal to negative 1. That becomes our new equation on the bottom here. Good there? Okay, top equation is done. There's no more x's underneath the x. That's great. Now we move on to the y value. So top equation remains the same, no change whatsoever. It's just tedious a little bit here. So that's done, no change here. Next, and now we're going to work with these guys. So our world of elimination again. The top equation, oh, real quick here, we can interchange things, right? For this one, do I have a y with the coefficient of 1 on top? Absolutely. I don't need to interchange anything. We good? Because I can interchange things as well. So if this had like a 3 in it or something like that, right? Then I don't like that one. I may have to interchange things in order to get that guy to be a 1. But it already has a 1 there. That's cool. Okay, so the top, I don't need to multiply anything because I already have opposites. We're good. So my second equation comes down, no change now. But I'm going to work with my bottom equation. So these two come into my elimination world. I don't need to change anything there whatsoever because the y is already opposites. I don't care about the z's because I'm going to get an answer for my z in just a second. Y's are gone. What does z become? 2z is equal to 4, and that becomes my new equation. 2z is equal to 4. Ha ha ha. Can I separate them out now? So here's my 3 equations. They are in row echelon form now. Well, almost. Got one more thing to do to put into row echelon form. What do we got to do to put in row echelon form? Just divide the bottom by 2. So can I write this out right over here? So I have x minus 2y plus 3z is equal to 9. Y plus 3z is equal to 5. And now z is equal to 2. There's my row echelon form. And I work backwards. Here it is. Since I know what z is, I plug in climbing up the ladder here. Y is equal to negative 1. Now that we know what y and z are, can you give me x?
Oh, it's just the same as example 1.
Uh-huh.
That would mean x would be 1.
Uh-huh. 1, negative 1, 2. Looks pretty familiar.
You don't have to put that next to it.
Oh, hey.
It's always gonna be x, y, z.
Yeah. Yeah, you
I
just
just
saw
noticed that.
that. Right.
That looks familiar.
Okay, talk to me. Totally confused, or somewhat confused, or I get this pretty easy. Okay, we're good. So first of all is totally confused, Mr. Gio. I have no clue what you just spoke for the last hour. A little bit confused, still a little bit confused. Okay, and I got this. This is easy. I'm all good to go. Okay. Time is up for us anyways, right?
Yeah.
Okay, so let's stop here. We'll revisit this again on Wednesday and finally put it together, but this is our first view with this piece right here. So come back on Wednesday, we'll finish it off.
I had one question that was just sort of when I was looking through